So we were discussing about single phase, full wave, controlled rectifiers. So full wave controlled rectifier means both the half cycles of the input voltage, that is a positive and negative half cycles, can be controlled. That's the meaning. So in a full wave controlled rectifiers we have learned, but this controller is also called a full converter. We have learned with R load, RL load. RL load we have two cases, continuous conduction and the discontinuous conduction. Then we can also try with RL with a freewheeling diode. We also learned what will happen when an RLE load connected across the terminals of this converter circuit. In RLE load we have two operations, alpha greater than 90 degree and alpha less than 90 degree. Alpha less than 90 degree is called the normal converter operation, and alpha greater than 90 degree is called the line commutated inverted operation. Line commutated inverter operation. Okay, because in this case when alpha greater than 90, the voltage will be negative in most of the times, so the power will be negative. That's why this is called an inversion mode of operation. Okay, so this converter circuit, the full wave controlled rectifier, is called full converter. Why? Because we have used all the four thyristors, all the four switches are thyristors. This is the diagram of a full converter circuit. We have thyristors T1, T4, T3 and T2. Okay, and we have loads like RL and RLE connected, T1, T2, T3 and T4. All the four switches are thyristors. Okay, now the same full conversion or the full wave rectification can be done by using another method. Instead of using these two thyristors, I can replace these two thyristors by normal diodes. Instead of this T4 and T2, this is become D2 and D4. I can replace the thyristors with the diode. The same operation will happen. Okay, the same full wave controlled rectification will happen here also. So this circuit where two thyristors are replaced by two normal diodes, this circuit is called semi-converter. The earlier circuit where all the four switches are thyristors, it was known as full converter. So you have to understand the difference between this semi-converter and full converter. Semi means only two thyristors and two diodes. Full converter means all the four switches are thyristors. Now the operation is same. You can use the same principle to draw the waveform. So today in this lecture we will be learning how a semi-converter works. So semi-converter means we have thyristors T1, then a diode, another thyristor, then again a diode, and assume that I am using an RLE load. Okay, also assume that I am using a freewheeling diode FD. This is the freewheeling diode FD, and this is thyristor T1, this is diode D1, this is thyristor T2, this is diode D2, and we will be applying the supply voltage here between these points A and B. Okay, so first we will draw the waveforms. We will draw the source voltage. With A is positive and B is negative, we can draw this VAB. The reverse case is with B is positive, A is negative, the reverse case is VBA. You can mark this pi, 2 pi and 3 pi intervals. This is pi, 2 pi and 3 pi. Okay, now assume that this is an RLE load, so you can draw this value of E here. Okay, and assume that I am going to apply my pulse here. This is the interval I will be supplying this, triggering T1 and D1. So I will be writing here T1 D1. This is the interval I will be firing T2 and D2 and T1 D1, etc. It goes on like that. Okay, so you can extend that also. The firing intervals, the alpha intervals. Now based on that, first you can, this is a source voltage, these are the pulses, okay, firing intervals, T1 D1 here, T2 D2 here, again T1 D1 here. Okay, now you can draw the current first. RLE loads, you can draw the current. We all know that it starts from, this is the value where T1 D1 starts its firing, this is called alpha, this is pi, this is another angle pi plus alpha, this is 2 pi, this is 2 pi plus alpha, it goes on like that. Okay, so the current starts its conduction at alpha and reaches somewhere between pi by 2 to pi. Okay, and once the current decreases after this Vm sin omega t less than E, current start to decrease. Whenever the change in current happens, the current initially was flowing like this. Whenever the value of Vm sin omega t is less than the value of E, what is going to happen is that the current start to decrease, because the current senses the opposition of E, it starts to decrease. So immediately what will happen is that inductor, initially when the current was flowing, this was the polarity of inductor. Now immediately inductor will reverses its polarity. Whenever inductor reverses its polarity, immediately freewheeling diode will conduct. So after this interval, when the negative half cycle starts, or this interval, what happens is that the freewheeling diode conducts. So when the freewheeling diode conduct, I am using a different color. This is the freewheeling diode conduction. Current continues to remain in its value. So it reaches pi plus alpha. At pi plus alpha, the next trigger pulse is arrived. So current again increases, and when it start to decrease, freewheeling diode will conduct. So current continues in that value, and after that it goes on like that. So if you are drawing a steady state current, you can draw like this. Okay, so the important thing is that you have to mark the conduction interval. So I am going to mark, this is the interval where T1 D1 is conducting. From alpha to pi, T1 D1 is conducting. Okay, from pi to pi plus alpha, who is conducting? Freewheeling diode is conducting, because the negative half cycle just started. T1 cannot conduct anymore. So what happens is that inductor will reverses its polarity and freewheeling diode starts to conduct. So from pi plus alpha to 2 pi, T2 D2 will conduct. Okay, here is the freewheeling diode conducts. So based on that, you can draw the output voltage. When T1 D1 is conducting, what is the output voltage? When T1 D1 is conducting, the current is from A, T1, then the load D1 back to B. This is the interval when T1 D1 is conducting. So output voltage is equal to VAB. So during this T1 D1 time, from alpha to pi, what is VAB? This is VAB. Okay, so you can copy this VAB and paste here. From pi to pi plus alpha, freewheeling diode is conducting. Whenever freewheeling diode is conducting, this is a circuit, RLE, load, and the freewheeling diode. This is the output voltage. So if you take the KVL, you can see that the output voltage V0 is equal to 0, or in other words, you can write R into I plus L into di by dt plus E is equal to 0. This is the whole value. R plus L into di by dt plus E is called the output voltage V0. So this V0 is equal to 0 during this interval. Okay, from pi plus alpha to 2 pi, T2 D2 is conducting. When T2 D2 is conducting, what's the circuit? It starts from B, T2, load, then D2, then back to A. So output voltage is equal to VBA. So during that interval, what is VBA? This is VBA. So you can just copy this VBA and paste it. So this is the output voltage. Okay. Now you can draw the source current also. The other waveforms you need to draw is source current IS. How will you draw source current? When T1 D1 is conducting, the current is taken from source, right? If the current is flowing from A, T1 D1 back to B, so the current is flowing from A to B. So you can copy this current and paste here as the source current. Okay, you can take this current, so the current will be like this, right? this portion you can copy this. This is the source current during that interval. From pi to pi plus alpha, what is happening? Freewheeling diode is conducting. When freewheeling diode is conducting, this is the circuit. There is no current from A to B or from B to A. So during that interval, source current taken from the source is also 0. And when T2 D2 is conducting from pi plus alpha to 2 pi, T2 D2 is conducting, but it is from B to A. B, T2, load, then D2, back to A. This is circuit. So from B to A, but this is the load current. So you can take this current and just reverse it. You take this current, copy this current and draw the reverse of this. So you will get the source current. Similarly, you can draw this VT1 and VT2 based on the circuit that we have previously done. Try to do it by yourself. Okay, so this is the operation of semi-converter circuit.